Now, what is the second change? Again, the second change requires an object-oriented programming for implementation. So let's check the second change here. So the second change is explained, I guess. Okay, yes, here we have it. So it says, the system actually operates 2 shifts a day. The system actually operates 2 shifts a day. And on the second shift, there are 2 operators assigned to the rework operation. Okay, so in the rework operation, remember rework was our bottleneck. And if you run your simulation, you will realize that there is a huge length of queue, a very, very long queue that is going to be observed in the rework process. But how do they solve the problem? They solve this problem by employing a single employee in the rework machine in the first shift. But during the first shift, a lot of items are going to accumulate in the queue to be processed. So they are just going to compensate this situation by adding one extra worker, extra machine, or whatever resource that you are going to use. They are going to employ 2 operators to the rework operation. And during the second shift, the queue that has been accumulated in the first shift is going to be reduced. Okay, so it is just going to be consumed, exhausted. Okay, so in the first shift, because we have a single employee, the length of the items waiting in the rework queue are going to increase and increase. But then in the second shift, they are going to decrease and decrease. Okay, so that is something that we need to add as a property, and this can be done with a schedule property. Okay, so let me show you how it is going to work. Now you see in the rework process here, if I click on the rework process, if I say edit via dialog box, I have a resource to use. Every entity that enters in the rework process uses the resource rework, and they use only one of, okay? Now, the number of rework machines here, the number of rework operators here, is sometimes going to be 1, sometimes it is going to be 2, depending on the shift that we have, okay? Now, the system, let's make our first change in the setup parameters here. Now, you see the replication length is 32 and the hours per day is 24. Now, if the system works for 2 shifts in a day, each shift consists of 8 hours. Now, instead of using 24 hours here, I can simply write 16 hours here, because a single day will consist of only 2 shifts, 8 hours plus 8 hours. Now, the replication length is going to be, let's just say 20 days, okay? So I am just going to run the simulation of this system again, but every day I am just going to experience 2 shifts in total of 16 hours, and a single replication will endure for 20 days. So in total of 40 shifts, And remember now my base time units is still minutes. Okay, now every day I am just going to experience 2 shifts, 8 hours in the first shift and 8 hours in the second shift. Now I am just going to go to resource module again, and in resource module I have a single prepay machine with a fixed capacity. I have a single prepay machine with a fixed capacity. Fixed capacity means what? Throughout the day, there will always be one machine. I have a sealer machine, again with a fixed capacity. I have only one of them. Now I have a rework machine, but I should not have a fixed capacity of that, because in the first 8 hours, I will have one rework machine or rework operator, and in the second 8 hours, I will have 2 rework machines. So it is not fixed capacity. So what I'm going to do, I'm just going to right click on the row and I will say edit via dialog box. And instead of fixed capacity, I will say that the capacity is going to change based on a schedule. Okay? And what is the name of the schedule here? The name of the schedule is going to be rework schedule. Okay, the rework schedule. Again, we have three rules here. One of them should be chosen. Wait, ignore, or preempt. We should choose one of them. Now, which one I'm just going to choose? According to the textbook, I am going to choose ignore. However, at this point, I need to explain what do these mean, schedule rules. Okay, and you see the same rules here under the failure rules as well. So what do these mean? I'm just going to explain the meaning of this to you. Okay. Now I'm going to back to textbook and I will show you a picture. Now let's just say we have a single resource. Okay, single resource. That resource works until the noon time, which is 12 o'clock. Okay. So we have, for example, a post office, and in that post office, there's a single officer that is working. So my resource, the size, the capacity of my resource until the noon time, until 12 a.m., okay, it is simply equal to 1. But at 12 a.m., my officer enters into noon holiday, okay? So the lunch time, let's just say. And at 1 p.m., the break ends. At 1 p.m., the break ends, and again, the officer starts to work. So until 12 a.m., the capacity of my employee is 1. From 12 a.m. to 1 p.m. in the noon break, the capacity is reduced to 0. Then the capacity is again increasing to 1. Okay? So we have a capacity change based on a schedule here. Okay? So according to this scheduled break, at 12 a.m., the number of employees working in the post office is going to reduce to 0. Then again, it is going to increase to 1. Now you see, at 12 a.m., the resource enters the lunch break. Let's just say at that time, there is a job that this officer has started but has not finished yet. So when he is going to finish this job? If the officer enters the lunchtime immediately at 12 a.m. and when the lunchtime ends and the officers come back and completes the task he has started before the noon time, then this is going to be called the Preemptor Rule. So in the Preemptor Rule, he is just going to enter the lunch break immediately and leaving the task half finished. And that task is going to be finished once he comes back when the scheduled break ends. So this is called the Preemptor Rule. Now, this is the wait rule. The second one is wait rule. What does wait do? So if the officer has a task to do, and if it is half finished at 12 a.m., he is just going to wait in the system until the task is finished. But after the task is finished, he is just going to enter the late lunch break, and he is just going to spend exactly 1 hour in this lunch break. Exactly 1 hour in this lunch break. So you see, his lunch break is going to shift for 15 minutes when you choose the wait rule. Okay? And he's going to come back 15 minutes later. So the remaining future events, they are all going to be shifted by 15 minutes. Okay? So wait is actually not a type of rule that we can use for an officer who works in the post office. And I think preempt is not a rule. Similarly, preempt is not a rule that we can use for a post office. Now, I mean, because in the post office, you are performing a task related with people, the clients coming to the post office, and you cannot just remain the business of a person half finished and make him wait until the lunch break. Okay? So this is not a possible case for an officer in the post office as well. But the third one, which is, as you can see, written incorrectly, is the ignore rule. And in the ignore rule, we have something like this. If before the lunch break, if the post officer starts a job, and if it is half finished at 12 a.m., he is just going to wait until this task is finished. Then he is going to enter the break, but he is going to come back again exactly at 1 p.m. So basically, he's going to use from his break. He's going to use from his break. Unfortunately, unfortunate for the officer here, the officer is going to consume his break time if he continues serving to the client here, and this is the ignore rule. So which schedule rule we should choose is explained here. At which page of the textbook? At page 135 of the textbook. So this picture explains the differences between the preempt, wait, and ignore schedule rules. And actually, we have chosen one of these rules in failure schedule as well, if you remember. So actually the same question is being asked there. If a machine fails, is it going to remain, is it going to leave the task that it is performing on half finished and continue after it is fixed? Is it going to, if it breaks down, is it going to continue the process and finish the task first, then it is going to enter into the repair process? Or if you choose the ignore rule, it is going to continue to perform the process, and its breakdown period, its breakdown downtime period is going to immediately start during the process, and it is going to end when the downtime ends. Okay? So again, we can apply the same rules in failure schedules as well. All right, so here the text tells us to choose the ignore rule, which means that machine is going to continue the process if, for example, in the second shift, we have two machines. Now, in the end of the day, what happens? In the end of the day, the second machine, it is going to continue working on the job, okay? Remember now, in the end of the day, again, to the next shift, we need to start with one machine only. So the number of machines is going to decrease. The second machine that we are going to use in the end of the second shift is going to continue the job that it handles, even though the shift ends. However, after completing this task, it is not going to be used. And again, it is going to be used when the second shift starts on the second day. Okay? Even though the shift ends, the machine is going to continue to perform the last job that it does until it is complete. Okay? So because of that reason, we are just going to use the ignore. We have not entered anything. So I have just explained the ignore rule here. We have not entered anything about the rework schedule here. So we have defined it here, rework schedule, and I'm just going to click OK on that. Now remember, this machine does not experience any failures, so we do not enter anything here. So we have entered a schedule name that is called the rework schedule, and I click on OK. Now if you check the schedule spreadsheet view here under the basic process panel, so we have, you see another spreadsheet that is named as schedule. Now in rework schedule, I have to edit it with the dialog box. I have a rework schedule which has the type of capacity, so it changes the capacity of a resource. Now the time units for this capacity change is going to be given in hours. Okay, given in hours. Now I'm just going to add my first value. I'm just going to have one resource for 8 hours. Then I am going to have two resources for 8 hours again. Okay, and that is the end of the list. So you see, for 8 hours, I am going to have one resource in rework schedule, and in the next 8 hours, I will have two resources in the rework schedule. Now, after 16 hours, that periodic event is going to repeat itself. So in the next 16 hours, again, in the first 8 hours, I will have one resource. In the next 8 hours, I will have two resources, and it is going to repeat itself again and again until the simulation ends. So this is the schedule that I have defined. Now, that gives me the capacity of a certain resource for how many hours, and the capacity of the same resource for how many hours, okay? So as you can see, I have defined the capacity schedule here, and that rework schedule, that capacity schedule is being used by the rework resource, okay? So as you can see, I have a rework schedule here. Instead of a fixed capacity, I have a type that is based on schedule, and I use the rework schedule here, and the schedule rule is ignored. Again, I am telling you this. If I define a schedule in a separate spreadsheet view, I can use the same schedule for another resource as well. So for example, I can assign a second prep B machine in the second shift again with a similar manner as the rework machines. And all I need to do is, instead of using the capacity here, I am going to use a schedule name, and that schedule name is going to be the rework schedule. So with one schedule that I have defined, I can change the capacity of two machines or two resources with the same schedule that I have defined. Because of that reason, I define the schedules in another spreadsheet view. Okay, so schedule is an object, and the resource, if it does not have a fixed capacity, then the resource can use that schedule if you like. Okay, so this is the second change that we have seen. Now you will see that if I turn on the animation, okay, let me decrease this to it. So sometimes I will have two machines, sometimes I will have one machine here in the rework process. Okay. Now, in fact, I can see that by changing that. So adding a variable here, I'm just going to add a variable here under the rework process, and I will use a build expression here. So this variable is going to be related to the resources and current number scheduled. The current number scheduled. I would like to see the current number scheduled in the rework process. So you will see that at every 8 hours, the number of scheduled resources is going to change. And the format here is an integer basically. Okay. So I am adding this. So you will see how many rework operators are scheduled here. Now let me run the simulation. Now we are in the beginning of the first shift. So the first shift consists of 480 minutes. I'm sorry, 640 minutes, because the first shift takes for 8 hours. So you see I have one rework machine right now. Okay. Now you will realize that through the end of the first shift, the queue in the rework process is going to increase. So you see right now I have two machines. Okay, unfortunately I have skipped it. I have two machines working, and the queue in the rework process is going to decrease, and it is going to increase when I have one machine working, and when I have two machines working, it is going to decrease. Okay, so in the first shift, the size of the queue increases. In the second shift, it is going to decrease. Of course, there will be some exceptions as well. It depends on the timing of the processes in the rework process. I do not remember the distribution of the rework process. As you can see, it is exponentially distributed, and you know, exponential distribution can admit a very, very large periods of time as well. And therefore, exceptionally, even in the second shift, we can observe an increase in the queue size. But you see, we have 1, 2, 1, 2. So these are the shifts that are changing, and the simulation is going to end soon. So in the second shift as well, you are seeing some parts. But in the first shift especially, the size of the queue is increasing, as you can see here. Now, in the second shift, in the next second shift here, they are going to be eliminated. Okay. So they have not been eliminated. They are increasing even more. Okay. Now let's check the next second shift, for example. Maybe they are going to be eliminated at that time. Actually, they are not eliminated because, I mean, I think that is the steady state of the queue. I mean, on the average, we always observe a large amount of objects in the queue.